Hey everybody, Dominik here. Today we're talking a little bit about Agile, and maybe not the typical Agile that you usually see with all the features and all the techniques that we're supposed to follow, but more about why your team is having a hard time adapting Agile. Because I hear so often about teams and companies having a difficult time with Agile methodologies and Agile techniques where they don't actually materialize. So let's take a look at what some of the contributing factors might be, because that might help you adjust the approach to implement Agile in your organization. Number one is a little bit of history. Agile actually came about in the early 2000s. There were a few people, pretty smart people I think, they gathered up and they discussed how they could do software projects better. And why did they have to meet up and figure out how to do software projects better? Because most companies and most projects followed what we know as the waterfall approach. And what did that result into? Delayed projects that went over budget, and some of them were not even ever delivered. So let's take a look at what the issue was of projects in the olden days and what still persists to today. So in the olden days, right, if you have a traditional approach with a waterfallish approach, you start out with requirements. Okay, so you meet up with all the stakeholders, you have a great meeting, you capture all the wishes and ideas that people have about what they would want in their software product. Okay, that's all good and well, so you write that down, you come up with the requirement specification, and it forms a contract of like, hey people, this is what we're going to deliver. Next, you go design something, you come up with some technical solution that you say, you know what, based on the requirements that we have, we're creating a design, and the design is going to have to look so and so. Okay, also awesome, sounds good, right? So we trace requirements to design and say, yep, for every item that we have in the requirements, we create the design, and that's going to be perfect. And then we're going to go build some stuff. Okay, so there's a lot of stuff to be built, whether, again, in that case of early Agile, it was software that was built. But obviously, the methodologies and techniques have easily been applied to other types of projects and other technology as well, because it is really a universal approach. So, okay, sounds good. So we went ahead and built some stuff. Looks good. We checked against the design. We check against the requirements. Yes, everything is there. And then we go test. And we check everything out. And then we get the user involved, maybe here. Or we even go and release the product that we have. And as soon as the user gets involved again, they're not happy. And then you say like, wait a minute, you gave us the requirements, we went through all this trouble for all these weeks and months of building that product to meet these requirements that you meant, and now you're telling me that this is actually not what you want or not what you intended it to be. Okay, so is that a problem? Yes, for most companies it is, right? Because if you don't get it right, this is weeks or months or maybe even years, hopefully not years, until you find out that what you have built and invested all your time and energy in is potentially gone to waste, or at least a huge portion of it. And maybe you also find out that some of the assumptions on the requirements early on resulted in a design that does not accommodate things that were truly needed by the poor user or the customer that has to pay the bills. And so then you're in a bunch of trouble, right? Because again, customer doesn't get what they want, user doesn't get what they want, and then you have wasted a bunch of time along the way. And so where Agile really comes into play, and you can go, I'll post a link to the Agile Manifesto, which outlines some of the basics for developing Agile, which other methodologies, including Scrum, eventually lead into. But what it essentially does is it reduces the cycle from a discussion about what's needed to the point of where the user is involved and can provide tangible feedback on a solution that's been developed, from these weeks and months literally to days. Right? So keep that in mind. The goal is not so much about dropping in a framework that just magically solves all your problems, or utilizing these techniques that are portrayed by the frameworks that might be able to buy or you train your people on. The ultimate goal is really to get to the point of a testable artifact as quickly as possible, where you get user feedback. And this is what creates these iterations that are ideally very, very fast, where you go from a requirement to a design to building and testing and releasing, even including user feedback along the way, right? So this loop right here, rather than having a straight shot from end to end, you want to make this as short as possible with many, many iterations along the way, with the goal of releasing a product as early as possible. And now you say like, okay, maybe that's all good and well if I develop a software application with, if I have to build something that doesn't involve any physical artifacts. Now, the counter argument to that is really to say, are there things in the real world where projects and systems have been built using such a methodology that involve physical elements? And there surely have. And I think one of the great examples is the SpaceX Starship, a gigantic rocket, right? It's probably, I mean, it's the biggest rocket that's ever been built, but it's a gigantic artifact. And what did SpaceX do? Instead of working towards a single approach to build that one perfect, fully functioning release of their space rocket, they built the prototype and launched it. And I think the first two, they even blew up, right? So they didn't get very far. But nonetheless, right, the team had set out objectives that they wanted to meet with their test. And so they built a smaller artifact, an incomplete artifact that was fully testable, gave them a lot of insights. It was released for a test with objectives, and the team was able to learn a lot from that for the next iteration. So even though you say like, oh my God, they just spent a bunch of money blowing up a gigantic rocket in midair, it helped in retrospect, and you can see what happened to the subsequent launches also of that rocket, that every iteration brought them further ahead. And so ultimately, if you look back on it, Agile development does not only apply to software, it applies to any really complex undertaking, because ultimately it's a risk mitigation approach to building something that's extremely, extremely complex. And you likely can't do in a single shot successfully, because either it hasn't been done before at all, in the case of SpaceX Starship, or your team doesn't have the experience with building an artifact like this from start to finish in a single shot. And most complex undertakings are very complex because they haven't been done before, because they usually take a lot of effort, because they're worthwhile to implement, to help a customer, to help people in the real world. And so Agile methodology, in the Agile methodology, the techniques that exist in these frameworks that we have are really backed by the experience of doing work in a sequential way, getting earlier feedback, iterating over your product, that you can improve it over time, and you don't have to rely on getting it perfect from day one. And again, think about this on your project from day one, and establish a culture where you accept that a team can deliver artifacts, a product that is not fully polished, that can be reviewed, given feedback on, and the feedback can then be incorporated into future iterations of the product. So in addition to the methodology itself and all the tools that we hear about, make sure that you have a culture that allows and accepts for incomplete products, for imperfect products that are being developed, because only then you have the best chance of moving fast, getting that feedback back into the loop and into further product development. The second piece that I want to tackle in that regard, and why it's so difficult for many teams to understand and live an agile approach, goes back to delivering this imperfect solution and sharing that with people. All our lives we have been trained to be assigned projects, starting from elementary school, where we get an assignment, we go do the work, we turn it in, and we get a grade. If we do a good job, we get an A. If we don't do a good job, we get something less than an A. And that has been burned into our ways of thinking for a long time. And all the work that we do, and most of the traditional programs that educate these days, are still working in that way. So we go, we get an assignment, we complete the assignment, and it has to be complete and ideally perfect to the expectations of the requester. And so if you look at this, how we're learning to go about doing your work, it's typically frowned upon to deliver an incomplete or partial result or product. And this is something that not only leaders have to adapt to accept that something is incomplete for the benefit of getting a result faster, but teams also have to understand that this is an acceptable way of working. Because again, you have to be comfortable with doing some work quickly, releasing and sharing what you have, however ugly it may look, but the focus is that you do that on a quick time frame, that it's in a matter of days and not in a matter of weeks or months before you share something. And understanding and accepting that as a technologist or an engineer or anybody really, to deliver something that is not fully perfect and fleshed out and flawless can be a difficult thing, and that can create some resistance in adopting an agile process. Because in agile, what do? You create iterations that are very short, as short as you can before you can review a tangible result again, get feedback on that, again, however incomplete it may be, and you spend the next short iteration cycle to refine on that. And so it highlights work that is being done in a much quicker fashion, right? There's less chance of pushing something out, there's less chance of delaying something, there's less chance of overspending energy on a feature that is being developed. So it's really these two aspects that we're looking for in transformation in an organization that adapts agile. It's one thing to learn the tools and techniques that are, again, available from various programs, product offerings, what have you, but to also really internalize the ways of working, that this is a way to get a result into the hands of people that can provide feedback much sooner rather than later, and being comfortable with delivering an imperfect artifact and getting feedback on that and not feeling bad about it. So think about that when you look at your team and adopting Agile, especially if your team is having a hard time with working in a different mindset, in a different approach that is much faster paced and relies on incremental steps and a lot of feedback in a rapid fashion. Let me know what you think. There's a couple of links below that I include with food for thought. But let me know how it's going with your Agile implementation and your team adopting Agile as a way of working, and your organization adapting to that way of working with rapid feedback, with much more involvement from all stakeholders. Until next time, talk to you then.